This video covers review day 1, the last half or the second half, pages 4 through 6. So for these, we are trying to look at quadratics. So f of x equals x squared. So 26 asks us to reflect, stretch by a factor of 1/2, translate up 2, and left 1. So to reflect, we need a negative in front. To stretch, we need a 1/2 in front. Inside will be our left or right. Left is a +1. And then to go up 2, we will add 2. Remember that your vertex is always the opposite of what's inside of x, the same as what follows. And this point from the origin would go left 1, up 2. If it reflects, it would have a minimum. Domain for all quadratics is all reals, and then we can draw it to see what our range would be. And then my axis of symmetry is always x equals the x from my vertex, so x would equal -1. So I go to -1, 2, and plot my vertex. It's going to reflect, so I'm going to go down. My normal pattern is right 1, up 1, right 1, up 3. So with a stretch by a factor of 1/2, I'm going to multiply every other number by 1/2. So 1, 1/2, 1, 1.5. And remember, these are reflected, so I need negatives in front of them. So I go right 1, down 1/2, right 1, down 1.5, left 1, down 1/2, left 1, down 1.5. So from here, I can see my range and 2 are related. This one is going down, so it will be less than 2. 27, stretched by a factor of 2, is going to go in front. Right 4 is going to go in the parentheses, and down 3 is going to go after the parentheses. Vertex is +4, -3. This one is not reflected, so it's going to be a minimum. Oh, I apologize. This is a max. So sorry. Domain is still all reals. Because we have a minimum, it should be greater than -3, because minimum means lowest point. And then axis of symmetry, x equals x from the vertex. I go to 4, -3 and plot my point. My stretching by a factor of 2 means my original pattern of 1, 1, 1, 3. Every other number gets multiplied by 2, so 1, 2, 1, 6. I go out or right 1, up 2, right 1, up 6, left 1, up 2, left 1, up 6. And we can see it is clearly skinnier than the original graph. Also remember, at any time that you're given a description in y equals, you can type in what you're looking at. So I did 2 parentheses x minus 4 squared minus 3. And if I click graph, zoom 6, graph, I can see my vertex goes to the right 4, down 3. It has a minimum and is a little bit skinnier than normal. Problem 28, you can plug into y equals, or just know from your patterns, your vertex is going to be the opposite of x, the same as y. There is no negative in front, so it's going to be a minimum. Domain is all reals. Because we have a minimum, range will be greater than. And then my axis of symmetry, x equals the x from my vertex. So my vertex is -2, -3. My pattern changes by 1/2. So we go right 1, up 1/2, right 1, up 1.5, right 1, up 1/2, right 1, up 1.5. And draw our graph. Now this one, we are talking about absolute value. Absolute value looks like a V. My pattern is 1, 1, 1, 1 for the original. This vertex, there's nothing inside with x and a 2 that follows. Because I have a negative out front, I will have a maximum. Domain is still all reals. Because I have a max, my range will be less than, and my axis of symmetry, x equals da, da, da. So I go to 0, 2. My pattern changes from 1, 1, 1, 1. We're changing every other number to a negative. So 1, negative 3, 1, negative 3. So I go right 1, down 3, right 1, down 3, left 1, down 3, left 1, down 3. And again, you can plug this in to y equals. And I'll do that on problem 30. So for problem 30, in y equals, I can type in what I'm seeing. I have 1/2 in front. To get the absolute value, you click Math, go to Number, and Enter. I can see this looks like an absolute value, so I can type it in exactly like I see it, so x minus 4. When I click Graph, I can see what it looks like. Also, remember, you can click Second Table to kind of get some points if you need to see like where it crosses the x-axis, etc. So this one, my vertex is going to be a positive 4, 0, opposite same, and there's nothing that follows. We could see from the graph there was a minimum, so therefore my range is going to be greater than. My axis of symmetry will equal the x from my vertex. And I go to 4, 0. My pattern is going to change by 1/2. So 1, 1/2, 1, 1/2. So I go right 1 up 1/2, right 1 up 1/2, left 1 up 1/2, left 1 up 1/2. Remember, absolute values are very symmetric. Okay, and that's kind of what my graph looked like. This graph is just scaled differently. It only goes to positive 6 and negative 6. But my graph does look like that. It's shifted to the right, and it's very wide. So problem 31 is going to look very similar, but just have a different stretch factor. Okay, so again, I've noticed that these are basically the same, just a different stretch. So 1, 2, 1, 2. So these patterns might be something you want to write down on your note card. Right 1 up 2, right 1 up 2, right 1 up 2, right or left 1 up 2, left 1 up 2. And as you're copying this down, remember that you can pause at any time. But this is what I'm looking at, and I can see my graph is a lot more narrow, more skinny than the original one, or the 1 in 30. So problem 32, my vertex is the opposite of what's inside with x, the same as what follows. This one will be a maximum because of the negative in front. So my range will be less than. Axis of symmetry is always x equals the x from my vertex. So I go to negative 4, 6. And my pattern is 1, negative 1, 1, negative 1. So right 1, down 1, left 1, down 1. And then the last part, they ask you, this should say defines the image of the absolute value of x under the following. So actually ignore this part in bold. Just write the absolute value equation in translation form or vertex form. So just the same form we've been working with. So I can see my pattern goes right 1 up 1, right 1 up 1, so I don't need anything in front of the absolute value, and it looks like a normal V, not an upside down V, so I don't need a negative. This one goes to the right 2, so I need an x minus 2, and it does not move up or down any, so that's all I need to put. Also remember that you could very simply type this into y equals if you're not sure if that's the exact equation, and either look at the graph or go second table and make sure these points here match the points that you are given in the original picture. 34, this one does not go left or right. It doesn't go up or down because my vertex is at 0, 0, but we go out 1 up 2, which means that I need a 2 in front of my absolute value. It does not reflect, so I don't need a negative, and again, it doesn't move left, right, up, or down, so that's the only part I need. 35 moves to the left 4, down 2 and goes 1, 1, 1, but also reflects. So I need a negative in front to reflect. Left is a positive 4, and down would be a minus 2 instead of a plus 2. And then 36, we go right 1, up 1, reflect, and we go 1, 1, 1, so there is no number in front. So negative to reflect, x minus 1 inside the absolute value to go right 1, and then a plus 1 to go up 1.